Now this question is the whole question is a differentiation question, but the part A starts with just simple solving an equation, right? There's no differentiation involved here, and it's a surd equation. Now these equations don't come up that often, right? But most people will know that to solve a surd equation or to deal with the surd here, you simply square both sides, right? And that gets rid of the square root then. Okay, after that then you end up with something that kind of reminds you of a quadratic, but as everyone should know at this stage, to solve a quadratic we need to get everything on the left hand side and it has to be equal to 0. Now after that then you have a couple of options as how to solve this. Some people use the minus b formula, some people use the guide number method, whereas whatever way you do it anyway, I would tend to use just factorizing it, right? Factorize the quadratic, there are your two factors and there are your two roots. Okay, and both of these solutions work for this then. Okay, so it's as simple as that, and it's a nice handy 5 marks to get you started. And this is where the differentiation comes in here. So we have a differentiation question and then kind of an applications of differentiation then down here, right? So when you're differentiating this, okay, it's the square root is what's going to cause the trouble, right? So if you were to look at it, the x itself here, like there should be no problem differentiating that. That just goes to 1. But the problem will be with this square root of x plus 6. Okay, and like you should be very familiar as how to do that. Now, what I'm going to do here is use the chain rule. Okay, now for the chain rule, what I say is you call the bit underneath the bracket u, right? So that's your u is equal to x plus 6, and then you rewrite this in terms of u, right? So that's, instead of saying the square root of x plus 6, we say the square root of u. Okay, now you then differentiate both of these. So differentiating that just goes to 1, that goes to 0. Now, this then, differentiating the square root of u, what I would suggest is you learn off the derivative of this, right? The derivative of square root of u or square root of x sometimes is just 1 over 2 root u. Okay, now if you want to do it the long way, that's fine as well, but like just bear in mind that the long method has about 5 or 6 different steps and they're quite tedious to learn. Now you probably do need to understand this and you do need to be able to follow this, but that would be just my kind of piece of advice. When you're asked to find the derivative of root u or root x, just learn it off, 1 over 2 root u. Okay, so now from the chain rule then, the chain rule says that if I want to differentiate this, I simply multiply the two derivatives in this case. So we just multiply 1 by 1 over 2 root u, which is fine, but then we sub back in your u here, which is x plus 6, and that's the derivative of that. So just that bit here, that's your derivative. So the entire derivative of this is going to be 1 minus this here. Okay, now that's might be kind of like, if you weren't familiar with all of this kind of stuff, that would seem very complicated, right? But hopefully, like whatever way you want to lay out your question yourself, hopefully you do have some appreciation as to how that's done. Some people know the kind of shortcut for doing the chain rule, right? Which is fine as long as you're comfortable with whatever you're doing yourself. Similarly here, some people just want to do it the long way, which is grand. But whatever way, this is your derivative anyway of this. So finally, for part C. Right, so find the coordinates of the turning point of this. Now, the key thing is that when you hear turning point, okay, even if you're not even quite sure where it comes from, the turning point, to find the turning point, you get your derivative, put it equal to 0, and solve. Right, simple as that. And we already have the derivative up here, so we want to take this derivative, put it equal to 0, and solve. So basically, it turns from a differentiation question back into an algebra question. We just simply need to solve this equation. Okay, now be careful with this, right? It's not as easy as it looks. So what I would be doing is just maybe getting the 1 on the opposite side, so we can do a bit of cross multiplication here, right? So cross multiply this over here, and again we're back with another algebra surds question, right? So there's 2 ways you can actually square it at this point if you want. Just say 1 squared is equal to all of this squared. But look, what I'm just going to do there is get rid of this 2, so divide it across by 2, and now I'm going to square both sides. So when I square this side, I get a quarter. When I square this side, I'm just left with x plus 6. And now we're just solving for x, so take 6 from both sides, and x comes out as minus 23 over 4. Right, so when a quarter take 6 is that. Okay, but we want the coordinates of the turning point. Right, so this is our x value. So to find the y value, you simply substitute this back into the original function. Okay, so you're subbing that back in here. And again, don't be turned off by the fractions here. That's what a lot of people have problem with here, is just they think fractions makes it more complicated, which it does slightly, but it shouldn't. The logic remains the same. Substitute your x value back in here, and that gives you your y value here. Okay, take as many steps there as you want. Some people will be able to type all of that perfectly into their calculator, but whatever way you want to do it anyway, this is your y value here. So they're your coordinates. Now you can use decimals to do this. You can change that to a decimal if you want and get your answer as a decimal, or you could do it as mixed number fractions as well. So that would be, whatever it would be 5 3/4, and this would be minus 6 1/4. Right, whatever way you want to express it, there's no problem there.